Okay, so today we're looking at the product rule, and we use this to differentiate when we have two functions being multiplied together. The first example, you could simply expand out the x plus 5 and the 2x minus 8 and differentiate it that way. But I'm going to show you that the product rule will give you the same answer. And then we'll look at a more complicated example and you'll see why we need a rule like this. But the rule says if y is equal to u times v, so a function u and a function v, and they're being multiplied together, then when you differentiate y, you get uv dash plus vu dash. So you keep the first term multiplied by the derivative of the second, and then you add on the second term multiplied by the derivative of the first. So when you get your function, the first thing you need to do is decide on your u and your v, and then we say, well, if u is equal to x plus 5, then u dash is just 1. And if v is equal to 2x minus 8, then v dash is equal to 2. So you work out what all your derivatives are first, and then you're going to substitute it in. Alright, so y dash is going to be equal to uv dash plus vu dash, which means that we do x plus 5 multiplied by 2 plus 2x minus 8 multiplied by 1. Then you need to expand out and simplify because we're obviously going to get some x terms and some constant terms that we can combine. So 2x plus 10 plus 2x minus 8, which leads us to 4x plus 2. Okay, so that's your derivative. Now, if you were to expand it first, you would get y is equal to 2x squared, and we would have plus 10x minus 8x, so plus 2x minus 40. So then when you differentiated that, you would get 4x plus 2. Same answer. You can use either method on a simple quadratic because hopefully you're pretty good at expanding the quadratics now. That's why it works. Excuse me. So looking at our second function, you can see that if you try and expand this out, it's going to get extremely complicated. You're going to have a huge amount of terms, and chances are in an exam situation, when you are trying to expand this out, you're going to make a mistake. You're going to forget to multiply something, you're going to get a minus where there should be a plus, something's going to go wrong, and mistakes are too easy to make. They also take way too long to expand these out. So using the product rule is much faster, much more efficient, much less chance of making a mistake. Alright, so again you start off by deciding on which one's your u and which one's your v. Okay, so then over to the side we do the let u equal 7x minus 2 all cubed. So then if I differentiate that, I get our 3, keep your brackets, subtract 1 from your power, and then multiply it by the derivative of what's in the brackets, which is 7. So that comes out to be 21 times 7x minus 2 all squared. Alright, and then I'm going to let v equal to x plus 1 all to the power of 4. So when I differentiate that, bring down my 4, x plus, whoops, we lost a 1, x plus 1, it's all cubed, and then you would multiply it by the derivative of x plus 1, which is just 1. So I don't need to write that out again. Okay, so that there is what I need to substitute in to my product rule. Okay, so when I start differentiating, we get y dash is equal to, so it's u, so keep your u, 7x minus 2 all cubed, times by v dash, so 4 outside of x plus 1 all cubed, and then it's plus, and then we go v, so x plus 1 to 4 times u dash, which is 21 outside of 7x minus 2 all squared. Okay, so just do your straight substitution first. Now again, you don't want to be expanding. You've got cubics times by cubics and things get yucky. But if you have a look at this, you've got some common terms. So we've got 7x minus 2, and I can take out 7x minus 2 squared because there's the 2 of them, yeah? And then I've got this x plus 1, there's 3 there and 4 there, so I can take that out as another common factor. Alright, so then when we start neatening this up, we're going to take out 7x minus 2, and I'm going to take out 2 of those, and I can take out x plus 1, and I can take out 3 of those. Alright, so then, now you see I'll use the square brackets here to show that we're going to have brackets inside of brackets, and if we use the same brackets, it's very easy to make a mistake. So we go to the square brackets, keep it nice. So from the first term, I'm left with 4. Now I only took out 2 of the 7x minus 2, so I've still got 1 left, but I did take out all of the x plus 1s. And then we've got plus, we've got the 21, and I took out 3 of the x plus 1s, so I've still got 1, but we took out both of the 7x minus 2s. Okay, so we can close off my brackets. Now you will be expected to tidy up what's in those square brackets, because you've got some common things that will simplify out. We've got some like terms. So inside that we've got 28x minus 8 plus 21x plus 21. So then just tidy it up, that's all. 7x minus 2 all squared, x plus 1 cubed, and then 49x plus 13. Okay, now the reason we want it factorized is because when we get later on into calculus, the zeros, so where this function is equal to 0, is going to tell us a lot. The zeros are going to tell us the turning points and stuff. So if you start expanding it out, trying to figure out where it's equal to 0 is not going to be easy. But looking at that factorized form, I can say, well, when 7x minus 2 equals 0, so x equals 3.5, this is equal to 0. When x plus 1 equals 0, so x equals minus 1, this is going to be equal to 0. Leave it factorized. Don't try and expand it. You'll make mistakes, and it's no good to you anyway. It doesn't give you any information. So that's what you need for this exercise. Practice it until you can say that rule in your sleep. Alright, good luck, and I'll see you in class.